most solids, we can apply a general volume formula. And the basic idea is that it is the area of the base multiplied by the height of the solid. Let's look at examples. Here are two prisms. We have a triangular prism and a rectangular prism. I can tell that there's a right angle because of this symbol right here. So this general formula means that we take the area of one of the bases. And remember, the bases are the shapes that are opposite from each other and congruent, and then they're surrounded by rectangles. So in this case, the bases are triangles. We want to find area of the triangle, and then we're going to multiply that by the height of the prism. Now I'm writing out height of prism because I want to distinguish it from the height of the triangle. This can get kind of confusing, so keep your bases and heights straight. The triangle has a base and a height, and the figure has a base polygon and a height. So just keep that in mind. So the area of this triangle is 1/2 times 2 times 3. And of course, I always reduce when I can before multiplying. So that just turns out to be 3. And in this case, it is square centimeters. Remember, this is area of the base, okay? Next, I take the area of the base and I fill up the figure, if you can imagine, by multiplying by the height. This is like taking layers upon layers and filling the figure with those layers. And that's why multiplying by 4 fills it up, okay? So we take our 3 times 4 and we get 12. And now it's volume. It's not square centimeters, it's cubic centimeters. And that is the volume using the general volume formula. How about this rectangular prism? We need the area of the base and multiply it by the height. So the area of the base is 2 times 3, and then we multiply by 4. This is pretty straightforward stuff, right? So volume is equal to 24 cubic centimeters. And it turns out that that's composed of 2 triangular prisms like the previous example. So we got volume is twice as big, which makes sense, right? So that's prisms. How about cylinders? It's actually the same principle. We need the area of the base, and then we're going to fill up the object by multiplying by the height. Okay, so let's do that. Now, if the diameter is 10, the radius is 5. And I have a habit of writing those down for any circular problem so that I don't accidentally use diameter or radius interchangeably. So for this particular problem, we need the area of the base, so we're going to use pi r squared, right? And then we're going to multiply the height of the object. So that turns into 25 pi times 15, which is 375 pi. And the units are cubed, in this case centimeters cubed, or cubic centimeters. And if you can picture filling that with cubic centimeters, they're going to bump into the edges a little bit, but that's what it is. So this is in terms of pi. Now what about other prisms with other polygon bases? We have the formulas memorized at this point for triangles and parallelograms and rectangles, but what about if it has more sides than a quadrilateral? Well, there is a general formula for the area of any regular polygon. So as long as the base is some regular polygon, we can still find the area using this new formula here. It uses a measurement called an apothem. The apothem is kind of like a radius, but really the radius of the polygon would go all the way to one of the vertices, and that's not what we're talking about. So some people call the apothem the smaller radius. But in any case, it's in the formula, so you need to know what it is. It goes from the center to the center of one of the regular sides, and it's perpendicular. So I've got that marked down here. I've got all your measurements you need, so let's do this. So we need that hexagonal area, and we're going to fill it up by multiplying by the height of the object. The formula for area of this base is 1/2 times the apothem, which is 5, times the perimeter. Okay, the perimeter, since it's a regular polygon, is 6 times 6, which is 36. And that's just area of the base. Then we're going to multiply that by the height of the figure, which is 15. So let's reduce our 2. It can go into 36. We've got 18 left. So really, we have 5 times 18 times 15 to get our volume. Okay, and that comes out to be 1,350 cubic units. And they're not marked, so we have to leave it in the generic form. And that is how you use the general formula for volume of solids. We'll talk about pyramids and cones in a different video. Good luck.